Welcome viewers to the Power System Protection Lab of National Institute of Technical Teachers Training and Research, Kolkata. Today in this session we are going to perform an experiment to show you how a inverse definite minimum time overcurrent relay performs. To perform this experiment we are going to use this trainer model, okay, and at the end of this session we are going to learn different units of this trainer model, the wiring sequence between these units, how to set this numerical overcurrent relay, okay, and how the relay is tripping when a overcurrent is given to the relay, okay, and finally we will draw a inverse time characteristics graph. Now there are 5 units of this IDMT overcurrent relay trainer. First we have single phase AC input panel to supply the input power. Next we have variable voltage and current injector panel to vary the input current. Next we have overcurrent and time elapse counter panel to see the values of the current and to see after how much time the relay is tripping. Next we have numerical IDMT overcurrent relay panel, and this is the IDMT overcurrent relay. Okay, this part and this part is connected from the back side, okay, and the wiring sequence between these different units is given in the instruction manual. Now we will start with relay setting. To set the relay we have to give it power supply. To give it power supply, here we have one 4 amp MCB, another 1.6 amp MCB, okay. Now we will start with relay setting. To set the relay we have to give it power supply, and to supply it the power we will turn on this MCBs. So now we will open the case to enter the menu. Press the menu button and we have 4 options: edit, protection, false and test. We will go to the protection option by pressing this right arrow. Now press enter. Here it is asking for the password and the default password is 1000. We can change this value using this up and down arrow. So now it is set to 1000. Now press enter. Here we have 3 options: pH, EF and CLP. Press enter to enter the pH option. Here we have active and inhibit. Set it to active. It is already set. Otherwise we can change it using this up and down arrow. Now press the enter button and it is set to active. Next go to EF option by pressing this right arrow, then press enter. Here we have 2 options again, active and inhibit. We will set it to inhibit. It is already set, so we are pressing this enter button. Now we will go to CLP option, press enter. Again we have active and inhibit option. We will set the inhibit option, so press enter. Now this part is set, so press the menu button. Next we will go to the edit option. Press this left arrow to go to the edit option. Now press enter. Here again it is asking for the password. The default password is 1000. So we are setting this to 1000 and pressing enter. Here we have phase, EF, CLP, descent and many other options. First we will go to phase. Press enter. Here we have to select this 3.0 second NI. Okay, it is already set, so we are pressing the enter button to select it. Next in this option we have to select this to 0050.0. It is already set, so I am again pressing the enter button. Next we have time multiplier setting, that is TMS. We need to set it to 1. It is already set to 1, otherwise we can change it using this option, okay, and this option, but it is already set to 1, so we are pressing enter. Next, as it is done, we are pressing this, selecting the inhibit option, so we are pressing enter, and now it is done. Next go to reset option. press enter, select hand, it is already set, otherwise we could select it using this up and down arrow. Now select hand and press enter. Now it is set. Next we will go to line CT, press enter. Here we have to select 0005/5 ampere, it is already selected, so we are pressing this enter button to select it. Again we are pressing this enter button. Now it is also set. Next we will go to frequency, press enter, select 50 Hz, because in India we use 50 Hz. In USA and other European countries they use generally 60 Hz. So 50 Hz is selected, so we will press enter. Now it is asking me to press reset to accept settings. Here this is the reset button, so press the reset button. Now it is done. Okay. Now the relay is set to trip at a value over 2.5 ampere. So far we have discussed about different units of this IDMT overcurrent relay trainer, the wiring sequence between them, and finally we have set this numerical IDMT overcurrent relay to a value over 2.5 so that it trips only a value over 2.5 ampere. Okay. Now we will supply the relay with a value less than 2.5 ampere to show you that it is not tripping. To do that, first we will make sure that this button, this bypass switch, is at its left position, it is in open position. Now make sure that this variable voltage and current injector is at its leftmost option. Okay. Now we will start this PB1 switch to set the value just below 2.5. So rotate this variable voltage and current injector clockwise direction to increase this supplied current. We will set it to around 2.4. So it is good enough. Okay. Now we will press this PB2 stop push button. Now we will press this reset button to reset the timer. Okay. Now set this bypass switch to close position. Now press this start push button PB1, and now you can see that the relay is not tripping. Okay. So we will press this stop push button PB2, set this to open position, press this reset button to reset this elapsed timer counter. Next set this to start. Next rotate it clockwise direction to increase the value to 5 ampere. It is near about 5. Okay. It is good enough. Next we will press the stop button, set it to close position, reset the timer. Next we will press the start button, and you will see after a certain time the relay will trip and the elapsed timer counter will stop. Here at 9.6 it stopped. Okay. So like this we will take several values, like for the third value we will take 7.5 ampere, next 10 ampere, next 12.5 ampere, up to 20 ampere. Okay. After getting the values, we have plotted the plug setting multiplier versus elapsed time graph, and this is the result. In this graph you can see that with increased value of PSM the elapsed time is decreasing. That is the property of IDMT overcurrent relay. In the next session we will discuss about numerical definite minimum time overcurrent relay. Till then, goodbye.